Okay, so today we're going to look at IP 10.5 and IP 10.6. So what do we know about residual plots? So residuals are calculated by finding the difference between the actual Y value and the predicted Y value. So that is true. Oh, let me collect the pen. So that is true. Residual should either be all positive or all negative. That is not true. Residual plots determine if a function is a good fit. True. The sum of residuals should always be 0 because the predicted value should be that close to the actual values. True. When the best fit line for a set of data is quadratic, the residual will have no distinct pattern. That is also true. All right, number 2, Beyonce recently posted a new music video on Twitter at 4 o'clock, and the retweets were tracked per hour after the post. The time and hours are tracked below. So A, which function should be used to fit the data? Well, hopefully you can see the data points are here. And so that follows more of an exponential function. So that means this right here would be the better fit. All right, so now we're going to complete the following table for residuals for the linear function of 138.9x minus 218 and 76/100. So we're going to move over here. And I'm going to kind of go down and then I'll move it up in a few minutes. All right, so we're going to take that and I'm going to rewrite it over here. So 138 and 9/10 x minus 218 and 76/100. All right, so we're going to substitute in that 1 so that we end up with the predicted value. So somehow the table has removed that. But anyway, this is predicted value, and this will be our residual. All right, so if we substitute in the 1, we get basically 138 minus 218 and 76/100. So that would end up with a negative 79 and 86/100. So then we subtract the 65 and this. So actually we would be adding, right? Because if it was a double negative, we would actually be adding. So if we add those together, we get 144 and 86/100. All right, then you go and substitute in 2. So if we substitute in 2 and subtract it, we get 59 and 400. And then basically subtract 90 in this, and we would end up with 30 and 96/100. Substitute in 162, so we would get 197 and 94/100. Subtract it, negative 35 and 94/100. So let me see if I can, yeah, there we go. All right, so then 224 would give me 336 and 84. This would give me negative 112 and 84/100. If we substitute in 337, I get 475 and 74/100. I get negative 133 and 74/100. Substitute in 466, so I get 614 and 64/100. So that would end up with negative 148 and 64/100. Substitute in 780, so I get 753 and 54/100, which gives me 26 and 46/100. All right, substitute in 1,000, so I end up with 892, 44/100. So 194.56. All right, then we're going to do the equation that goes with the exponential function. So the equation is here. Once again, substituting in 1 through 8. So if we substitute in 1, we get 70. Didn't like that larger version. Let's try this again. 72, 40 and 47 hundredths. Once again, subtract. Then this one gives me 106 and 53 hundredths. Subtract it and I get negative 1653. 156.60. So that gives me, actually positive 5 and 4/10. Substitute in 230, substitute in 4 and we get 230.20. Subtract it, I get negative 6 and 2/10. Substitute in 5, I get 338 and 40 hundredths. So subtract it and I end up with 3 and 6/10. Substitute in 466. End up with 497 and 45 hundredths. So this would give me negative 31 and 45 hundredths. Substitute in 7, so I get 731 and 25 hundredths. Subtract it, I get 48 and 75 hundredths. So if we substitute in 8, I get 1,074 and 94 hundredths. Subtract it, I get 12 and 6/10. All right, so D, let me move this over, says which function had more alternating residual values. So as you can see at top, we have quite a few negatives, but these seem to be going back and forth. So that would be the exponential. Not sure why it keeps going down, but anyway. All right, so now we're going to sketch the graph for the linear function. So once again, guys, we're just going to kind of guesstimate where these are because they're not going to be exact. So at 1, so that would be the graph further up. So at 1, we were at 144. So 144 is going to be somewhere right there. At 2, we were at 30. So that's going to be somewhere here. At 3, we were at negative 35. So that's going to be somewhere there. 4, negative 112. So if this is 120, it's going to be somewhere right there. 5, negative 133. So 120, it's 140, so it's probably right there somewhere. And at 6, negative 148. So this is 140, so it's going to probably be right there. 7 is at positive 26. So if this is 20, it's going to be right there. And at 8, it was at 194. So if this is 200, it's going to be somewhere right there. Okay. All right. So let's look at the exponential module. All right. So 1 and negative 7. So this is 10. So 7 is going to be right there. Don't know why this is doing that. So 1, let's try it again. Not liking it. It's definitely not liking being enlarged. All right, so 1, okay, so at 2, negative 16, so 2. Guess we're just going to have to do it with a smaller. All right, 3 is at 5, so 3, 5. 4 is at negative 6, so somewhere there. 5 is at 3.6, so somewhere there. 6 is at negative 31. 7 is at 48, so 48 would be here. And that was 8. All right, so we don't have a 9. All right, so as you can see, the question G says, which model most accurately represents the data? Justify your answer. So remember, the closer those points are to 0, the better the fit. So this would be exponential. So we're going to put because they are closer to 0. All right, so that is 10-4. So let me zoom back out, move this back where it's supposed to go. Okay, and then we're going to move this way. Gotta love it. Gotta love technology. All right, so let's look at 10-6. So 10-6 says if a data set has an exponential thread and a linear function, it fits to the data. What will the residual plot look like? So if a data has an exponential trend and a linear function is fit to the data, what would it look like? So we're going to draw our graph, and it would look something. So all my data points would be kind of together. And it would give me that kind of a V, but not really a V. It's that linear or that exponential. Okay, so something like that. All right, number 2, consider the scatter plot shown below. So what is the difference between these scatter plots? So scatter plot 1, okay, is not a good fit to the model. Because we have a well-defined pattern. Okay, what about scatter plot 2? Well, as you can see, there is really no pattern. And the residuals are scattered above and below 0. All right, number 3, a model was fit for a data set using the linear regression. Residual plots for the 2 data sets are shown below. Determine and justify which one could represent the data. So, all right, so we're looking at this. So as you can see, there's 1, 2, 3, 4, 5, 6, maybe 6 above 0. And then all the rest of them are below 0. So we're going to say many data sets below 0. Okay, and if you look over here, pretty even, right? So we're going to say there is no pattern. And the residuals are scattered above and below 0. Okay. All right, so let's look at the back. So, does a residual plot show a good fit for the model that was used for the data? Oh, well, that kind of disappeared, didn't it? All right, so number 4 was supposed to look something like this, or actually A of number 4. I think we missed. Let me go over here and see if it's down there. Yeah, you can kind of see it here. Anyway, here it is. So I guess when I moved it over, it didn't bring it with it. But it says, consider the following residual. Does the residual plot show a good fit for the model that was used for the data? So because we have a bunch of points here, right? And a bunch of points there, the answer would be yes, because there is no pattern and the residuals are scattered. All right, so looking at part B, it says describe the model was fitted to the data. Determine if the residual plot of the previous page could represent the data. All right, so we can look at this and we know that this is a linear function. And do this represent? No, because it just, yeah, it gives me that quadratic there. All right, so plot 2, hopefully you can see, is definitely a quadratic function. Okay, and as you can see, those residuals or those points are really close to that line. So we're going to say yes, it is a good fit. All right, what about plot 3? Well, you can see it's a linear, right? Linear function. And pretty good fit, right? About as many points below it as there is below, above and below. So yes, good fit. All right, so let's look at this line. So this line is a linear function. Okay, but as you can see, these residuals follow an exponential, right? So we're going to say no, not a good fit. All right, so that is it. So I used a little different of approach. So I used the Microsoft Whiteboard, and then I used my little tablet. So let me know what you think. Do you like this way better, or do you like me using the document camera? All right, you guys have a good day. Make corrections as needed.